Okay, we were just figuring out domain, and like I said, you do have the domain of a radical on your final exam, so there's another little look at it. We haven't done it since the beginning of chapter 6. So square roots require that whatever's underneath must be 0 or positive. So this is what means 0 or positive, greater than or equal to 0. And so that's the domain of f of x. So what is the range of f of x? What can y be? So when we take the square root of something, square root of 36, positive 6. Square root of 25, positive 5. So remember in chapter 6, we learned that square roots can only give us positive answers. They can also give us 0, because square root of 0 is 0, right? So y, the f of x, must be greater than or equal to 0. I can get 0, I can get a positive, but I can never get a negative answer for y. So this is the range of f of x. So when we go to write the domain of this inverse function, remember how x and y were interchanged? So the range of f of x must be the domain of x. So replace that with x and we get x is greater than or equal to 0. So that would be the domain of f inverse. And if they ask the range, which they usually don't, it would be this. So the domain of f becomes the range of f inverse. The range of f, and again, how I got the range is I looked at all the scenarios, and the only answers I can get from square roots are positives or 0. So that means the range is greater than or equal to 0. So it becomes the domain of the inverse, because Connect will ask you this. They'll ask you on the final, what's the domain? So find the range and domain of the original function, take the range of the original function, and that becomes the domain of the inverse. So these are the two things that you need for that. Find the inverse, state its domain, which will always be the range of this. So if the domain or range isn't limited, like on this one, there won't be any problem with it. It can be anything because x isn't limited. It's not under a radical. It's not in a denominator. So the only time x gets limited is when it's in a fraction and it's in the denominator. Remember, x cannot equal 0, x cannot equal 4, or when it's under a radical, because this value has to be positive. So that's why we wrote this. So you definitely want to practice on this section because it uses a lot of old stuff, but it's not something you're just going to be able to watch the video and become really good at it. So let's go ahead and start on the next one. Like I said, we won't have our domain and range will be negative infinity to positive infinity on this one because we don't have an x in the denominator. We don't have an x under a radical. Those are the things that limit the domain. But this one, we had the radical. That's why we had to deal with it. Okay, let's follow the steps. Step 1, make f of x y. So y equals 8x minus 5 over 4. Step 2, interchange your x and y. So y becomes x becomes y. And remember, don't just memorize the steps, understand why you're doing them. We interchanged x and y because that's the definition of an inverse. It's when x and y have been interchanged. So step 3 is to get y alone. So shall we do the whole cross multiplying thing again? Anytime one side's a fraction, I always do that. So this side will get 1 times 8y minus 5, which is 8y minus 5, equals, and this way we get 4x. So the whole reason we did that was to get rid of the fraction. We really don't want to work with fractions. So we set our cross products equal. This cross product is 8y minus 5. This cross product is 4x. And now we need to get y alone. So add 5, add 5. So we get 8y equals 4x plus 5. And last, to get y alone, we do the opposite, which would be divide by 8. So we get y equals 4x plus 5 divided by 8. And then remember, our last step is to tell the reader what we found. We've just found the inverse of f of x, so label it as such. F inverse of x is what we just got, 4x plus 5 over 8. So that would be our final answer. Okay, so 4 easy steps. Replace f of x with y. Step 2, interchange x and y, because that's what inverse means. The x and y get interchanged, so the y became x, the x became y. Step 3, get rid of the fraction by setting your cross products equal. So 8y minus 5 from this cross product equals 4x. Step 3 is get y alone. So I did the opposite to move the 5 over, and then I did the opposite to move the 8 over. So the opposite of subtraction is addition. The opposite of multiplication is division. So I end up with y equals 4x plus 5 over 8, and I don't need to divide them or anything. That's just, once you get y alone, you're done. So then step 4 is replace y with f inverse of x to show the reader that you've just found the inverse of the original function. That's probably the one most like what I would put on the final exam. So that's a good one to study. I know it's just like the one I had on the original Chapter 8 test. So that would be a good one to study. No restrictions, again, because there's no radicals and no x's in the denominator, so we don't have to write any of this down. So the domain would be x is any real number, because is any real number, there we go, because there's no restrictions. You can put a negative in, you can put a positive in, you can put a fraction in, so x is any real number. Okay, let's go ahead and look at 8. So step 1 is replace the f of x with y. Step 2, we're finding the inverse, and I know the definition of an inverse is interchange x and y. So step 2 is easy to remember because I just look at the directions. So y becomes x, x becomes y. Step 3 is get y alone. So I'm going to move my y over to the left. So y squared minus 7 equals x. And then it's easy for me to see. To get it alone, I need to add 7. Y squared equals x plus 7. And then how do I undo a squared? What's the inverse of squared? Square root. Square root. And so we don't add a plus or minus on this because see how this says x has to be greater than or equal to 0. So we don't add a plus or minus on this because this tells us x has to be positive. So we just write y equals square root x plus 7. And changing it to our notation, f inverse of x equals square root x plus 7. So that is my inverse function. So I tell the reader what I've just found. This is the inverse, so I label it as such. But now we do have a radical, so we have to do domain again. And like I said, I put this on the final, so this is good practice for the final. So x plus 7 must be positive or 0, because if I put a negative under a square root, I get imaginary numbers. So for it to be positive or 0, I write greater than or equal to 0. So x plus 7 greater than or equal to 0, because a negative would produce an imaginary number. Subtract 7, subtract 7. So x is greater than or equal to negative 7. So that would be the domain of f inverse of x. And again, why did I have to do it? I didn't have to do it here because they'd had already done that for us. So they already told us what x could be. But because we ended up with a radical, we have to make sure that radical is a real number. So if I put anything less than negative 7, like put negative 8 in it, then I get the square root of negative 1, which is I. So that's why I have to do that every time I have a square root. Take the radicand, make it greater than or equal to 0. And this is in your chapter 6 notes, so if you want to look back at that. But like I said, I did give you a problem like this on the final, and I said find the domain. So you need to know these steps. Okay, so this is the inverse. This is the domain of the inverse. Okay, so let's go ahead and answer questions down here, and we'll get a graph one of these. We started it on the first page. So state the domain of f. So I can see it goes left forever, right forever. So the domain is negative infinity to positive infinity. And domain is left and right, and this is just going to keep going left, and it's going to keep going right because of the arrows. Well, the range is the same thing. It's going to keep going down, and this is going to keep going up, because remember, domain is left to right, and range is bottom to top. So it goes down forever, up forever. So guess what? Our range is the exact same as our domain. So it goes left forever, right forever on the domain, because domain are the x's. But the range goes down forever and up forever. So we also have all real numbers on the range. So if you were paying attention throughout the lesson, we learned that the domain of f is the range of f inverse, because the x and y get switched. And the range of f is going to be the domain of f inverse. So we don't even have to draw the graph to answer those questions, because the x's of f become the y's of f inverse, and the y's of f become the x's of f inverse. So let's go ahead and finish drawing our graph there. So here's the line y equals x. It's already drawn in for us, and that just means all the x and y's have the same coordinates, 1, 1, 2, 2, 3, 3, 4, 4, and so on. So we plotted our first point on the first part of this lesson. So negative 2, 0 went with 0, negative 2. This looks like about 0, 2, so let's do, it's a little above, so we'll go a little past it. 0, a little bit bigger than 2, so that means a little bit bigger than 2, 0. And here's a point 3, 3. So when you switch the coordinates, it's still 3, 3. And let's find a point down here. This is negative 3, 5. So switch the coordinates. It's 5, negative 3. Whoops. Come on, Kim. Negative 3. Whoops. That has to be orange. Negative 3, negative 5. So switch the coordinates. It's going to be -5, -3. So do you see the graph?